Hi everyone, let's solve this problem binary tree maximum path sum. So this question is asked in all the FAANG companies and also Adobe and many more companies. So let's try to understand the problem statement and solve it. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an connecting edge. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. So basically what they're trying to say is, let's say there is a two nodes 2 and 3. There are connecting edges between them, and also they're saying that one node can only appear at max once and the path need not pass through the root. In that, what they're exactly telling is, let's say for example I take 15, 20 and 7. This can be also a path, right? So it does not have to pass through the root. The path sum of a path is the sum of nodes values in the path. So if I take this path, it's 15 plus 20 plus 7. That's the path sum. Given the root of a binary tree, return the maximum path sum of any non-empty path. So now let's try to understand it further. So let's try to do left, right and root traversal, post order traversal basically, and let's try to understand this. So at this particular point of node, I will consider if I include this node, what is the maximum result possible. Okay, that is how we are going to define our function. So since we are doing post order traversal, we will be traversing on the left side first, and 9 is the child node and there are no children further. So what is the, let's also maintain a variable result. As of now it is minus infinity because we want to find the maximum value. Now it's 9. So if I just consider this single node, what will be my result? My result will be 9 because maximum of minus infinity and 9 will be maximum. I have updated my answer. I will be moving back to the root and then we will be moving on to the right, and this node also has a children 15, so I will be moving here. When I move here, let me also write what am I returning from every node. Okay, at 15 there are no children node, and if I just consider this node, the answer will be 15. And among 15 and 9, what is maximum? 15 is maximum. Now if I return 15 here, now this is, if we consider this root node, we are done with left, but we are yet to consider the right value. So I will move on to the right, and it does not have any children further, so it's, if we just consider this particular node, it will just return 7. Now as I mentioned initially, if I consider this node to be included in the path, then the answer would be either root dot value or root dot value plus left or right, or it can be root dot value plus left and right. Because if let's say for example, if I am getting 15 and 15 and 7, they are both positive values. If I add them up, they will be like, the result value will be increasing, right? So I will go with this case. But let's say for example, if I have a, by like, just consider that this is a minus 7 instead of plus 7. 15 plus 20 minus 7, 35 minus 7, it would be 28, right? If we just consider 15 plus 20, it would be 35. So I would rather choose only this path instead of all 3 nodes. So that is how these conditions are here. And it might also happen that this is also minus 15, and minus 15 to 20 minus 7, it might give us lesser value. Then in that case I will just choose root value. So these are all the possible cases for a particular node. So in this case I'm just making it as plus 15 and plus 7 to avoid the confusion. In this case we are going with this particular condition, but there can be conditions where we are just taking root value, or we are just taking the combination of root value and left, or root value and right. It might also possible. Now in this case, once I get 15 and 7, at this particular position I have 20 plus 15 plus 7, that is nothing but 35 plus 7, 42, right? I will update my answer as 42. Now when I am returning this, let's say for example, when I am here, if I am returning the left answer, I can either have a path like this or I can have a path like this, but I cannot have a path like this, right? Only one side of the tree I can take, right? So which is the maximum of these? It's 20 plus 15, that 35 I will return it to the root. Now at this root point I know that it is minus 10. So again these 3 conditions are applicable. Root dot value, we will not go into this condition. We will consider this root dot value minus 10, and so since both of them are positive, we will take this one if we have to include the value. So in that case minus 10 plus 9 plus 35, what did I get? Minus 10 and minus 1 plus 35, it will be 34. But we already have a better answer than 34, so we will not be updating our answer. So we will have a better answer here, 42 already, and we will be returning it. So I hope the solution is clear. So just to give you insights, when we are calculating at a particular node, we will check on all these conditions, but when we are returning the maximum on a particular side, left or right, we will be choosing only one path of it. We will not be choosing a subtree along with a path, like this is a path and then this is a subtree. We cannot choose that. So I will be just returning the maximum which was available in one particular path, either this or this. That's the only thing we need to understand. So now let's try to code this up. As I mentioned initially, it will be minus infinity, and at the end we will return maximum sum. So we are writing a method to traverse the entire tree. So if it is a null node, there is no value for that node, so we will just return the 0 value. And first we will be traversing the left. Left value is nothing but traversal of root dot left root dot right. Now as I mentioned, we will be either choosing that value or leaving that value when we are considering these cases. So how are we going to do that? Math.max of left value comma 0. If it is negative value, we are not going to take that node. That's how we are removing that. Right max math.max of right value comma 0. Now once I get it, I will be updating my answer. My answer is stored in max sum, so I will check with the current value which is already existing, and at this particular point I am already checking this, and I am checking this root dot value and left and right. So root dot value plus left max plus right max. So these conditions all have these values already addressed. So that's the reason we are, because if we are checking OR, if one of them is negative, it will be replaced by 0. So 0 plus right will be only right value. If it right is 0, if only left is there, only one left will be the value there, right? So we are going to handle that using the maximum of it. Now once I update the maximum, we are returning mat.max of so at this particular point of time, we know that this is the root value, and we are returning maximum of left or right. So in this case, what am I going to do is I am going to return root dot maximum of root dot maximum of left max comma right max plus root dot value, right? This should be good enough. Let's try to run this up. So this is accepted. Let's submit it. It is accepted. Now let's try to understand the time and space complexity. Time complexity is big O of n because we are traversing all the nodes at max once. So that is the reason. And space complexity is we need the traversal recursion stack. So it would be big O of n in worst case, because if the tree is a skewed tree, then it would be big O of n. And also we are using just variables here, like 3 or 4 variables. It is big O of 1, so it should not matter. So this is the time and space complexity of the solution. I hope the solution is clear, and thank you.